In this video, we are going to go over section 7.1, functions of several variables. The goal of this section is to work with function and get familiar with an equation involving more than one variable. Sometimes we have an equation where we have multi-variable instead of just the x. So here's the definition. An equation of the form z equals f of x comma y. This describes a function with two independent variables, which is the x and the y. And then the function z is determined by those two independent variables. Here's some example that involves two functions. Area of a rectangle, we have a x times y, length times y, two different variables. Volume of a right circular cylinder, we have a r, radius, and height. Those are two different variables. And then, of course, the pi 3.14. Compound interest problem is more than two. It involves three different variables, four different variables, principal, rate, n, compounded number of times, and then t, the time in years. So you can see that a lot of a mathematical equation involve more than just one variable. So 7.1, we are going to get familiar with these notation and these order pairs. And 7.2, we are going to start adding a calculus part to it. So 7.1 is pretty simple, just getting familiar with the notation. So let's take a look at number 1. This function f is described in two different variables. You can see that x and y are those my independent variable. Whereas number 2, this function is described in three different independent variables, x, y, and z. So these order pair will match up. The first number will indicate the x, and then the second number will indicate y. So simply, we are going to find the f of 3, 4 by plugging in 3 for x, 4 for y. So we have 4 parentheses 3 square plus 2 times 4 square plus 5 times 3 plus 15. And then let's keep going and simplify. That's 4 times 9. 2 times 16 plus 15 plus 15. So I have altogether final answer 98. Let's do one more. This time we have three different variables. 0 will represent x, y will represent 2, and then z will represent 4. So simply plug it in. 0 to 4. So 5 times 0 cube plus 2 times 2 square minus 4 times 4 cube plus 5. This will be 0. This will be 4 square 8. And then we have 4 times 64 plus 5. So I have 8. Oops, I made a mistake. This should be minus because we have a minus here. 8 minus 256 plus 5. Final answer, I get negative 243. Okay. Pretty simple and easy. Okay. Let's take a look at more example. Number 3, again, this one, function a, is described in three separate variables, p, r, and t. So one more similar problems. I'm going to plug it in PRT as a 2000.03 and then 10. So a 2000, comma 0.03 comma 10 will be p, so that's for the first variable 2000 plus 2000 times r, which is 0.03, and then t will be 10. So I get 2000 and then plus this whole thing changes to 600. So final answer 2600. sometimes you may not give every value. So take a look at this one. X is given, y is unknown. So in this case, you will just replace y with just y. So g of 5 comma y will be, this will be my x value. So wherever you see x, you're going to replace with 3. 2 times 5, but y just remains the same because y, we are not given any value. Minus 4y plus 3. So I have 125 plus 10y squared minus 4y plus 3. Combining and then rearranging, I have g of 5 comma y as 10y squared minus 4y plus 128. That will be my final answer. Okay. Let's end with a one of the application problem. Okay. So a Cobb-Douglas production function for a company is given by f of x comma y equals to 50, x raised to 0.3, y raised to the 0.7, where x represent utilization of labor, y represent utilize of capital value. If the company use 1,500 units of labor, so notice the keyword labor, so this value will be my x. And then 1,200 units of capital, so this will be my y value. How many units will produced by the company? So this is very simple. That means I want to find f of 1,500, comma, 1,200. So I have 50x, which is 1,500, 0.3, and then we have 1,200, 0.7. So plug it in, everything into a calculator, I get about 64,154 units. Okay. That's it for section 7.1. Pretty simple. Now we are going to add one more part to it, taking the derivative. So that will be 7.2. So let's jump onto the second part, 7.2. So 7.2, now we are going to learn how to take the derivative of these multivariable function. So here we have to be careful. In the past, we are given one equation, so we just take the derivative respect to x and then come up with the derivative function. Here we have a term partial derivative because we have a choice now because you have a multiple different variables. So for example, if I'm looking at this function here, I can take derivative respect to x or respect to y. So when we say the term respect to x, that means take the function z respect to x. Another notation will be f of subscript x, x comma y. So that's taking the limit as f of x comma y plus h minus f of x. We are taking limit that approaches to h. Respect to y means you're taking the derivative, your variable is a y, so you will take the derivative respect to y. So all these three notation is means exactly the same. Now, in the past, we learned how to take the second derivative, third derivative, fourth derivative, and so on. So same thing here. You can take the second derivatives. So that means in this case, you'll take the second derivative by taking the first derivative respect to x and another x. Here, you're going to take the first derivative respect to x and then y. Here, you're going to take partial derivative y first and then x. And then here, you have a y and y. So you have a choices. So for the complete function 2 variable, you have 4 second order partial derivatives. So this is the definition. We'll practice bunch of practice problems. So let's begin with the very first one. Find the indicated first order. So this time we are only going to take derivative once. And then they give you the variable. Here, respect to x. So respect to x. This one, respect to y. And here, respect to x. So this means, it's a first time, so let me write a word. This means we are looking for the partial derivative with respect to x. So that means we are going to consider only the x as the variable and other variable as a constant. We are going to treat x as a variable and then other variable as a constant. So therefore, we consider only the x as a variable and all other variable as constants. Okay. So let's try this one. So that means term by term, I'm going to differentiate respect to x. Here, because x is the variable, x is the variable, and then 9 and y is just a constant. So how do you take the derivative of x squared? That's 3x squared, but we have a constant 9 and y attached. So you're going to end up having, so for example, here, just looking at the first term, 9 and y is a constant, so it doesn't change. Derivative of x squared will be 3x squared. So this will be my first term derivative. So you are going to have 27, 9 times 3, 27, x squared y. So I took the derivative respect to x and then treat the other variable as a constant. So let's do similar thing here. I'm going to highlight which variable I'm going to take the derivative. That's x. So derivative of x is just 1. So really I have 5y to the 4th power. This part is a constant. Remember, y is a constant, so it disappears. Derivative of 8x will be 8, and then derivative of constant disappear. So this is my final answer. Okay. So nothing different. We still use the same derivative rule, but we just have to be careful which variable we are going to differentiate because we have multiple different variables. Let's take a look at number 2. This time, we are taking the derivative respect to y. Therefore, we'll consider only y as a variable and all other variable constants. So let me write one more time and then I'll stop writing it. We are looking for the partial derivative with respect to y. Therefore, we consider only the y as a variable and all other variable as constants. Okay, so let's start term by term. First one, y is my variable, so derivative of y is 1. So 7x is a constant, so 7x will be my first term. Second one, remember, y is a variable, so 2x is a constant, so they disappear. Y is a variable, so in fact, if you want to, you can always highlight the y to begin on the whole entire equation, so you remember which variable you're taking the derivative. So 8y, derivative of 8y will be just 8. Derivative of y cubed is 3y squared with this one makes it negative 11x 3y squared. And then this one is a constant. So my final answer 7x plus 8 minus 33xy squared will be my final derivative function. Okay. dz dx is the same thing as f of x. We are taking respect to x here. So this another means take the derivative respect to x. Okay. Respect to x means my y variable will be constant. So I'm going to highlight the x. Let's take the derivative. So dz dx will be the first term. Y is a constant, so the whole thing disappears. This part, derivative of x is 1, so negative 2y. Derivative of 7x, derivative of x is 1, so plus 7. The constant disappear. So dz dx is equal to negative 2y plus 7. Okay. Now let's take a look at the next one where you have to take the derivative and plug in the value. We also did that in chapter 2. We differentiate and then we are given some value to plug it in to find the function value. So this means, notice here it's a f of y, so that means take derivative respect to y. And we practiced this one in 7.1. This will represent x value and this will represent the y value. But let's first take the derivative function. So f of y of x comma y will be, again, I'm going to highlight it so that I don't get confused. Y is the variable, y is the variable, and y is the variable. So x is a constant. Derivative of y squared is 2y, so 3x squared times 2y. Plus, derivative of y is just 1, so I have 5x. 8x is a constant, so disappear. Next one is 2, and then constant is just a 0. So my f of y, x comma y will be 6x squared. Oh, I'm sorry, x cubed. Should be x cubed. 6x cubed y plus 5x plus 2. Now, one more step. We want to plug it in 0 and 3. So let's plug it in. So that means 6 times 0 cube y plus 5 times 0 plus 2. So this will be 0, 0, 2. So my final answer will be 2. Okay. So we are done with taking the first order derivative. Now let's start taking derivative twice. Second order derivative. So here, number 5, we are taking derivative with respect to x and then x. Here you take the derivative first one. First derivative will be y first and then x. Okay. And then we have a little bit more function, one involving ln and e function, and then an application problem. Okay, so let's start with, first we'll find the partial derivative respect to x. Okay, so we'll start with first derivative f of x, x comma y. It's this part here. So again, x is my variable. So x squared is 2x, so with 7 multiplying, I have 14x for the first term. Y is my constant, so they disappear. Derivative of x is a 1, so 8y minus 8y. And then 17 is a constant, so it disappears. Now, we are not done. They want you to take another partial derivative second time respect to x again. So this will be whatever we did here. I'm going to take this time respect to y. So my y is the variable. So 14x, that will be the constant. So they disappear. This is only surviving with -8. Okay. So that's it. So you just have to keep pretty straightforward with. Don't mix up the variable. Okay. Differentiate term by term with respect to the correct variable. So first one on number 6, y first, and then second derivative will take a x. Okay, so this time let's start with the y. F of y, x comma y will be, this time y is your variable, x is the constant. Derivative of, let's recall, derivative of e to the u is eu du. So it will be e to the 3x squared plus 2y squared plus 6xy. Then derivative of this whole thing here. So y is your variable. So this is constant. 2y times y will give you 4y. And then derivative of y is 1. So it will be just 6x. So my final answer, f of y, x comma y, will be 4y plus 6x, e raised to 3x squared plus 2y squared plus 6xy. We are not done. We still have to take the derivative respect to x. So I'm taking the second time. From the first one, I'm gonna differentiate with respect to x. So x is my variable function. Okay. Now here, notice that this is a product rule. We need product rule because we have this function times the e function. So the product rule is f g prime plus f prime g, right? We take derivative, rotate it. So first one, this one stays the same, 4y plus 6x. Now derivative of this function respect to x, so kind of similar to this one. So it will be e raised to 3x squared plus 2y squared plus 6xy. But respect to x, so I'm going to have 6x constant. So they disappear. And then 6y. So that will be my first part. We need to add derivative of this here respect to x. So this one, it will be cancelled out because it's a constant. So 6x will be 6. And then derivative of this whole thing, e 3x, not the derivative, the original function, 3x squared plus 2y squared plus 6xy. Okay, let's do a little bit of a rearrangement here. One thing you can do is you can factor out this. Because they both have it. So to make it simple, so let's go ahead and then factor that out. E raised to the 3x squared plus 2y squared plus 6xy. Then inside I have 4y plus 6x times 6x plus 6y plus 6. So let's FOIL this one. And then add 6. So 4y times 6x will be 24xy. I have plus 24xy 36x squared plus 36xy plus 6. So finally, doing rearrangement. Uh, 36x squared plus, we have 24xy plus 24xy, 36xy. So that's going to be 24 plus 24 plus 36. I get 84. xy plus 6. That will be my final answer here. Okay. Similar thing here. Look, you can see that first one, we have a second derivative. This one is just the first derivative. So let's also practice a couple more. The last one before we go into a application problem. So I'm going to first take the first partial derivative respect to x. So I'm highlighting all the x here. So I have first term, I'm gonna have 3 times 12, which is 36x squared. Second one, derivative of x is 1, so it will be just 5y. And then this will disappear because it's a y. And then plus 4, constant. So 36x squared plus 5y plus 4. We need to take one more second derivative respect to x again. So from this, again, I'm going to highlight the x term and take the derivative. So this will be 72x, and then remaining one will be just constant. Okay, so my final answer will be just 72x. Number 8 will be s of first derivative y, and then we plug it in with the given value 4 and negative 4. So let's start with just taking the derivative respect to x and respect to y. So it will be this one that we are dealing with. And I'm going to highlight the y because y is the function that we want to take the derivative. So first one, x squared ln y. This one is actually a chain rule, right? I'm sorry, product rule. We have a x squared ln y, so f g prime plus f prime g. So it will be x squared derivative of ln y will be 1 over y. And then derivative for x squared, because x is constant because we are taking derivative of y, so this will be just 0. So I'm getting x squared over y for the derivative. For the first term, x squared over y. Second one here is also, again, a product rule. So let me write it out. So 3 e to the 2x y squared. Let's do that. So this will be my f, this will be my y. So let's take the product rule. So this will be 3e to x. Derivative of y squared will be 2y. And then derivative of this here. Well, x is just a constant. So this whole thing will be just a 0 times y squared. So in other words, it will be just this term, 6e2xy. 6, in other words, 6y e raised to the 2x. So that will be my derivative function, the first order derivative. Now, second one we need to evaluate. So let's plug it in. 4 comma negative 4. X will be 4. So 4 squared here. Y will be negative 4. 6 times negative 4. E raised to 2 times negative 4. 2 times positive 4. So this will be 16 divided by negative 4, negative 16, minus 24e raised to the 8th power. Using the calculator, I get approximately negative 71546.9917 as a final answer. Okay? All right. The last problem involves a application problem. So let's take a look at our last example. A firm produced 2 types of toy train each week, X of type A, Y of type B. So we have 2 different toy train. And then they're given the weekly revenue and then cost function. So revenue, the R function, and then cost function. Find the profit function and then find P of X when we have 800, 1000 and then P of Y 800, 1000. So first our job is to find the profit and recall from chapter 2, profit function is basically the revenue function minus the cost function. That will show you the pure profit. So let's first begin finding the profit function. So I'm going to have this subtract this. So 50x plus 70y plus 0.07xy minus 0.04x squared minus 0.04y squared minus 7x plus 9y plus 18,000. Now let's distribute the negative. So P of xy is equal to the first term will stay exactly the same. So I'll copy here. And then second one, when you distribute it, the first term is negative 7x, negative 9y, negative 18,000. So let's combine terms. So we have x squared alone. So P of x comma y, I have negative 0.04x squared. And then I have the xy function. I think this is the only term that has a xy, right? So plus 0.07xy. And then we have a x function. We can combine negative 50x with negative 7x. So that's gonna make negative 57x. Oh, oops. When I copy, should be positive 50x. Made a mistake when I copy. This one is 50x. So 50 minus 7 will be actually negative positive 43. Let's combine y's. 70x minus 9y will give me positive 61y. And then minus here 0.04y squared minus 18,000. Okay. Now Let's start with the first one. We need to take a partial derivative respect to x for this one and then plug it in. Second part, we take the partial derivative here respect to y and then plug it in. So I'm gonna begin with this one. First, let's take the partial derivative respect to x and then I'll plug it in 800 and 1000. So this time x is your variable. So x will be your variable function. I'm going to copy this one because I'm going to be using it in a minute. So here I have, let's highlight x, and that's it. So the first one, the derivative here will be bring down. So I'm going to have a negative 0.08x. This part, derivative of x is 1, so 0.07y. This one will be plus 43, constant. So my p of x comma y is negative 0.08x plus 0.07y plus 43. So let's plug it in with 800 for x and then 1000 for y. So negative 0.08 800, 0.07 1000 plus 43. Plug it into the calculator. I got 49 as our profit. Okay. In dollars. Okay. Similar thing, I'm going to do P of Y 800, 1000. So I'll do that on the next page. So I'm going to copy and then take derivative respect to y. So I will highlight all the term that involves y. Here, and here. So the first term is gone because it's a constant. Derivative of y is 1, so it will be just 0.07x. And then this is a constant, so it disappears. Plus 61. Bring down, so negative 0.08y, and then constant disappear. And we are going to evaluate 800 for x and then 1000 for y. So 0.07 times 800 plus 61 minus 0.08 1000. Plug it into the calculator. I'm getting final answer 37. Okay. All right. That's it for section 7.1 and 7.3. Next one, we'll go ahead and then talk about the concept of minimum and maximum that we did in back in chapter 2. Okay.